So welcome guys tonight and thanks for joining this weekend. And today we will finish this today our fourth or fifth lecture on basic statistics. So last lecture we completed our 1 hour 40-minute lecture on central tendencies, like we studied maximum minimum variable, range, which is maximum minus minimum, quartile, which is the positional variable, percentage, which is the percentage is the variable by value, quartile is the variable by position, interquartile range. You know, Q1 is 25 percentile, Q3 is 75 percentile, interquartile range is Q3 minus Q1. So mean middle 50% part of the data set, that is interquartile range. Then variance, we saw what is variance. We see variance unit is always squared, and standard deviation is nothing but the square root of variance. Its unit is same as the data. Okay, that's what all we studied. And we had a very nice discussion that day, yesterday. And now today we are finishing these two things. I have around 15 slides on skewness and kurtosis. Around 15 slides are there. So I hope to finish it in 1 hour 20 minutes. So let's stay tuned. That's what I'm telling. So let us start our lecture. Any questions from the past lecture, guys? Any question?
No, sir, it was actually...
Gajendra, Jitendra, Jignesh?
No, sir.
So today we are going, our main topic is skewness today. What is skewness? So I told you that normal distribution curve, which is perfect Gaussian curve or bell curve, it is symmetrical towards on the center. Its mean, median, and mode are on the same place. Mean equal to mode equal to median. And if you take mean in the middle, on the right and on the left, we have symmetry. Okay, so how you plot that curve? You take values of x on x-axis and frequency on y-axis, and you plot the curve. And if you divide, you want to convert with little effort, you can convert that frequency values to probability value also. Okay, so that both are your curve shape will remain the same. Like whatever frequency values you have plotted on the y-axis, you can convert very easily. You can convert it into probabilities. So it's also very basic, but in some other lecture I will tell you how to do that. So now in many measurements or many experiments or in many engineering measurements, we assume that there are multiple values. Like in measurement, there are same thing multiple times we measure. So there are different values. And each time, like each suppose you are manufacturing 100 bolts. So each bolt is supposed to be 10 mm. But if you measure it, little bit variation will be there. Some bolt will be 10.05, some bolt will be 10.99597, like that. Some will be little below, some will be little above. So as long as they are in a range, lower range to upper range, they are acceptable. So whenever we have multiple, like same measurement, we have multiple values. So we can always plot a distribution. Right? Okay, we can always plot the distribution. Value x1 came 10 times, x2 came 20 times, x3 came 40 times, like that. So this frequency we can plot on y-axis, and value of x1, x2, x3 we can plot on x-axis. This is how we can plot. So in many phenomena, we assume that the distribution is normal distribution or a bell curve or a Gaussian distribution. And if we know that it is a Gaussian distribution, then we know many properties of Gaussian distribution. So it is very easy for us to calculate probabilities, total probabilities, cumulative probabilities. It is very easy for us to calculate once we know that this curve is a 3 sigma, 2 sigma, 1 sigma values, 95% confidence, 99% confidence interval. Those kind of things we'll study in some future lecture. Couple of more lecture down the line, we'll study all these things. Right now, I'm just telling you. If you know something, some measurement is set of measurement is follows normal distribution, then things become very easy for you. But what happens many a times in real practice, there is very difficult to get a perfect bell shape like that. So generally your data is skewed. Data is skewed means, I want to tell you like what is the meaning of skewed data. So it is like this. Data is like this. Generally, either left-hand side slope is longer or right-hand side slope is longer. This longer slope is called tail. Pooch, tail. It's called a tail. So either a left tail is longer. If left tail is longer, it is called negatively skewed. And if right tail is longer, it is called positively skewed. So data is skewed. Then we are in trouble here. Because we know everything about normal distribution. We expect the plot to be a normal distribution, but we see that our experimental data, whatever we are getting from our measurement is not, see bolts we are measuring, same bolt we are measuring a different part. But our this plot, X1, X2, X3, bolt diameter on the X-axis and their count is on Y-axis. That if I'm plotting, I'm not getting a bell-shaped curve. I'm getting a skewed curve like this. Then what to do? I have to proceed, right? I cannot stay, oh, I cannot do anything now. I cannot proceed because it is not a bell curve. So you should know how to deal with a bell curve, how to deal with a skewed curve. That also you should know. So that's why we studied skewed distributions, okay? So there are many formulas and it is a very complex science in statistics. We are not going into there are several formula to measure skewness and to the ways to deal with, but we are not going deep into that statistical and mathematical part. I'm taking you to the qualitative part of here. That what is skewness, how to read the skewness, what are the implications of skewness, what is Pearson median skewness, a simple measure, how to take advantage of the Pearson measure. There is a simplest measure which is called Pearson median skewness. It is called Pearson's median skewness. It is used to measure the skewness. Like suppose some data is skewed like this. Data is skewed like this. So in some plots, the left curve may be little longer. In some plots, left tail can be very long. So how to measure that? We cannot that it is a short tail, long tail, medium tail. It doesn't mean anything because it is a qualitative measurement, and qualitative measurement has a different meaning to every person. We should be conveying it with the help of numbers. So we should know how to measure skewness. So there is a very simple formula. So there is a fact that in a bell curve, mean, median, mode are in the same place. So mean equal to mode equal to median. Now you have some piece of data. You are measuring 100 bolts of 10 mm. Some bolt is 10.02, one is 10.05, one is 9.97. Like that, you have 100 measurements. You plot them and you see that data is skewed. Data is skewed means what you have to do to find, suppose you don't want to plot them. How can you find out whether you have a skewed distribution or a perfect normal distribution? Just calculate mean, median, and mode. It is very easy. In the Excel also, you can calculate mean, median, and mode. There are very simple formula to calculate mean. There is a very simple formula to calculate median. There is a very simple formula to calculate mode. All these formulas are available in your Excel only. You can apply simple formula and calculate. So simply calculate mean, median, and mode. If they are different, that means your data is skewed. If they are same, mean equal to mode equal to median, then that means it is a perfect normal distribution. You are lucky. But if your mean is not equal to median, is not equal to mode, that means you have skewed distribution. So for every skewed distribution where left tail is longer or right tail is longer, your mean and mode, mean mode and median, mean, median, and mode will never match. They will be different. So that is the first test of a skewed distribution. Now so we take the advantage of this property that in a skewed distribution, mean, mode, and median are not the same. They are not equal. So we have devised, there is one gentleman called Pearson. he has devised this simple means to calculate skewness. So it is called Pearson's median skewness. This coefficient is called Pearson's median skewness. It is 3 times the difference between mean minus median. You can calculate mean median very easily given a set of data. So mean minus median 3 times divided by standard deviation. So given a set of data, Excel sheet itself will give you the standard deviation also. You can calculate mean, median, mode, standard deviation. In the simple Excel, you can calculate that. In simple formulas, you can calculate. So all these things are very easy to calculate when you have a set of measurements. You can calculate, so you know mean, you know median, you know standard deviation. Use this formula to get your Pearson median skewness. It is a formula to measure, a coefficient to measure skewness. So now how to read it? After that, you will get some value. So now there is some value, the value may be 10, 20, 2, 3, -2, or -5. So you should know how to interpret it. Like if some value comes in front of you, so suppose you are measuring, you are a doctor and you are measuring temperature of a patient. If temperature comes 97 or 98, you know that it is a normal temperature, so he is not having fever. His temperature is above 99, 100 or 101, you say it is heavy fever. Okay. So like that, you know how to interpret thermometer. Thermometer is showing you some number. It will not tell you whether patient is having fever or not. It will not tell you. It will show simple number. Suppose number is 100, blindly you will tell this guy is having fever. So he should be given crocin or Dolo 650. Those kind of things should be given, and it should be investigated. Why he is having a fever? So maybe because of throat pain, because of throat infection, is like some other infection he is having, or some malaria he is having. So doctor has to investigate. But doctor knows. Thermometer simply throws the numbers in front of you. 99, 98, 97, 96, 100, 101, 102, 104. Beyond 105, we are dead. Okay, so those kind of things. So doctor knows. So if the temperature number thrown at you is 104, then doctor is worried. It is 104 temperature. Simply they will lie you on the bed and they will put some ice, some sheets they will take, towel, and dipped in ice water, and they will keep on your head. Keep on changing it till your temperature comes below 100. So doctor knows what to do. And doctor knows the number which thermometer throws at you. So now similarly here, you know mean, median, standard deviation, you know all these things. You apply this simple formula. One number will be thrown at you. Oh yeah, this is the number. So how to interpret that number? Like doctor interprets the temperature. The doctor interprets thermometer number. Like that, we should be able to interpret what is Pearson median skewness. Okay. So this is how you have to interpret. Real observation rarely have Pearson skewness exactly equal to 0. Okay. So if this Pearson median skewness number is equal to 0, that means there is no skewness. Data is perfectly normal. There is no skewness. That is one indication. If Pearson skewness coefficient is 0, how? When it will be 0? It will be 0 only when mean is equal to median. Okay, for it to be 0, numerator should be 0. So when numerator will be equal to 0? Numerator will be 0 only when mean is equal to median. So you need not even apply this formula. If your mean and mode and median are equal, you can simply say that I don't have any skewness. Beyond that, how to read this particular coefficient. Okay, so now let us read. So there is a simple calculation to make your things. So median in this case is, there is some set of data, and median is 48.6, median is 39, mean is 48.6, and standard deviation is 39.5. That is what you put that data into Excel sheet, and applying formula, you have got this value from the Excel. Now just put in this formula. So 3 into mean minus median upon standard deviation. So 3 into 48.6 minus 39 upon standard deviation is 39.5. So now Pearson median skewness has come as 0.73. Now Gajendra Bhai will be in like thinking 0 means I know there is no skewness. Now this is a positive 0.73. What should I interpret with this? What is meaning of 0.73? Whether it is a heavy skewness, whether it is negatively skewed, whether it is a positively skewed. So that you should know how to interpret it. So you got 0.73. 0.73 you got Pearson median skewness. Very easy to calculate. Now let us see one more formula before that I want to introduce. Generally, when your data is skewed, your mean, mode, and median are not equal. So whatever I have highlighted in yellow, you should remember this formula. How it derived, we are not getting into detail, but you should remember. If you if mean minus mode, if you take a difference between mean and mode, it is approximately 3 times the mean minus median. You see this highlighted, yellow highlighted formula. Difference of mean minus mode is equal to approximately equal to 3 times mean minus median. That's what relation holds good. If your skewness, if there is a skewness in your data, you calculate mean median mode through Excel sheet, using Excel sheet or using Python, using whatever tool you want, you calculate mean mode median. So this formula will always apply. If you take the difference of mean and mode, it will be approximately equal to mean minus median. This is simple. This many numerical problems or many engineering problems you can solve with the help of this formula. And above that, I have repeated a simple Pearson formula, which is nothing but 3 times mean minus median upon. So it is called either Pearson median skewness, or that is also called Pearson's second coefficient. That is 3 into mean minus median upon standard deviation. So this is a simple, it is called Pearson median skewness or Pearson second coefficient. Both are same thing. And formula is given here. So we know that. Apart from that, one more new formula we should remember. Mean minus mode is equal to 3 times mean minus median. So this also is a formula which we can apply in our many situations. Now let us see how to interpret number. This skewness, Pearson second coefficient or Pearson median skewness number we got. So how to interpret this number? Try to read with me the bullet point 1. If skewness is between minus 0.5 to plus 0.5, the data are nearly symmetrical. Generally your Pearson coefficient, if you calculate for any kind of measurement, you will get near to 0, but you will never get 0 because data is never fully symmetrical. You will get near to 0, very near to 0, but you will not get perfectly 0. That is how you have to remember. That is one thing. If it is very near to 0 or between minus 0.5 and 0.5, that means we treat the data as symmetrical. We treat that data is normally distributed. One thing. So if it is minus 0.5 to 0.5, Pearson coefficient, if it is between minus 0.5 to 0.5, we treat our data to be symmetrical. We apply all normal Gaussian distribution formulas and all things which we can do with Gaussian distribution will be happily do. If skewness is between, minus side we are going, minus side, okay. If skewness is between minus 1 and minus 0.5, now we are going beyond minus 5, left hand side. Minus 5, minus 0.5 to minus 1 means it is less than minus 0.5, minus 0.5, minus 0.6, minus 0.7, minus 0.8, minus 0.9, up to minus 1. It is called negatively skewed because negative sign. So it is negatively skewed. So left tail is longer. It is left tail is longer. Left tail means if it is in minus, skewness coefficient is minus, that means it is first diagram. Left tail is longer. Okay, that's what we get. Or between 0.5 and 1, positively skewed. So if it is between positive 0.5 and 1, then this one right hand side curve will apply. It is positively skewed. If Pearson coefficient is negative, then this negative side will apply. Negatively skewed. This is positively skewed. But there is one more thing to be remembered. Between 0.5 to 1, data are slightly skewed. It is not, it is skewed data, but skewness is not that high. So now we are taking between minus 0.5 to minus 1 and plus 0.5 to plus 0.1. Plus 1, plus 0.5 to 1 and minus 0.5 to minus 1. That means either negatively skewed if negative sign, positively skewed if positive sign, and if skewness number is between minus 1 to plus 1, then it is slightly skewed. Slightly skewed means skewness is not that high. If skewness is lower than minus 1, means minus 1.5, minus 2, minus 3, minus 10, minus 15, anything below minus 1, minus 50, minus 60, it is highly skewed, negatively skewed. So minus 2 means it is highly negatively skewed. And if it is more than 1, more than plus 1, so 1.5, 1.75, 2.5, 2, 3, 4, 5, whatever number is more than 1, then it is highly positively skewed. Okay. So that's how you have to interpret this. So near to 0, you are very lucky. 0 is almost impossible, you will never get. But if your Pearson coefficient is near to 0, you are very lucky. Enjoy. Apply all the properties of Gaussian distribution. You are happy. If it is between minus 0.5 to 0.5, still you are happy. You can still apply Gaussian distribution because we don't consider it as skewness. We consider it is Gaussian distribution. So minus 0.2 minus 1, suppose you come, without plotting, you can say it is negatively skewed. And with plus 0.5 to 1, you can say it is positively skewed, but skewness is okay, under control. But if it is lower than minus 1, say minus 2, minus 3, minus 5, or it is higher than 1, 2, 3, 4, 2.5, then we can say data is extremely skewed. Extremely skewed. So that is how you have to interpret it. Now you tell me, guys, this data 0.73, how to interpret this? Gajendra, you have to interpret this now.
Slightly positive skewed.
Slightly positively skewed. Very nice. So this is slightly positively skewed. Okay. So now you got it. And so this is how you have to interpret it. Important for us is to get between minus 0.5 to plus 0.5. That is important for us to get. If we get that, we will apply Gaussian and we are very happy. Our problem will be very simple. But if it is between minus 1, minus 0.5 to 1, minus 1, it is slightly skewed. We are still okay. Between plus 0.5 to 1, it is positively skewed, but slightly skewed. Okay. But it is less than minus 1, minus 2, minus 3, minus 5, or more than 1, 1, 2, 3, 4, 5, then it is highly skewed. Then your problem is little more troublesome. Okay, so you are more deep in trouble. So now, these 2, 3 things we have learned. One, what is skewness? Why we study skewness? We study skewness because in normal practice, our data will be skewed only. Then very less cases you will get a perfect Gaussian distribution. So you should know how to deal with skewed data. That's why we study many engineering problems, engineering measurement, experiments will be your data set up. You are measuring same thing. But those, if you plot it, your data will be skewed. If you find this mean, median, standard deviation, anybody can find out. It is taught in class 8th or 9th. Anybody can find out using Excel sheet or simple formulas. So you know mean, median, mode, find out standard deviation. All this with that apply here, get Pearson skewness. If number is negative, say it is negatively skewed. If number is positively, say it is positively skewed. If it is between minus 0.5 to 0.5, say it is okay, got Gaussian distribution. Okay, we still use Gaussian distribution. And if it is less than 0.5, less than minus 1, or greater than plus 1, then you say it is highly skewed. So between minus 0.5 to minus 1, it is slightly skewed. Between plus 0.5 to plus 1, it is plus 0.5 to plus 1, it is slightly skewed. So that's how we read it. So these things we have learned. We have done a simple numerical and we got Pearson coefficient and we now know how to interpret it. So these are the very first things we have learned about. learnt about skewness. Now tell me, guys. Now I'm measuring of same 100 bolts. Expected diameter is perfect 10 millimeter, but 10 will never come. It is machine. Operator is operating it. So perfect 10 will not come. Perfect 10, generally these worker call it 00. If it comes perfect 10, the worker call it 00. So you can say 00 will never come. So how to do? It will be either 10.01, 10.02, 9.97, 9.99, like that data you will have. So like that 100 measurement, 100 bed bolts you measure, 100 set of measurement, diameter measurement you will have. So suppose now you plot it, or you calculate this, our friend Pearson's plotting is difficult. So you just calculate this mean median mode and standard deviation and calculate this Pearson coefficient. Very simple. Very like even a kid can do it. You teach to your child, he can calculate 8th class student, he can calculate Pearson coefficient. Mean median anyway, he knows how to calculate. You teach him one more formula, 3 into mean minus mode median upon standard deviation. That is Pearson. You teach him how to interpret it, he will also learn it. If you tell him that it is below -1, then it is highly skewed. Above +1, highly skewed. Like that, if you teach him, he will learn. So it says difficulty level is 7th or 8th grade. Even 5th grader will learn it. Yeah, if you teach him, a 5th grader properly, he will learn all these things. So now you are measuring a bolt. You are a quality control guy. 100 bolts you have measured. And around 10 millimeter, little variation in 10, you got 100 measurements. And now you calculate your Pearson coefficient and you found the data is negatively skewed. And you find that skewness, let us not get into skewness, whether it is more or less. We are telling data is skewed. Now what to do? Ideally we want data to be perfectly normally distributed. We want Pearson coefficient between -0.5 to 0.5, but it is not there. It is say slightly more than 0.5. So it is skewed. So how to deal with it? How to deal with it? Now you have to deal with it, right? Next is, as a QC engineer, you have to deal with it. You cannot say that I will reject the bolt. So bolt cannot be rejected. You should know how to deal with skewed distribution. Okay. Now, how to deal with? So 3 ways here. First is do nothing. Kuch bhi mat karo. Just keep quiet. Why? In many tests, there are many tests we can apply. All these tests we'll learn in our future lectures. T-test, ANOVA test. These are tests we'll learn. So these T-test and ANOVA test, and suppose you want to apply machine learning algorithm on this, which is linear regression. Suppose you want to apply logistic regression, linear regression, machine learning algorithm, or you want to do statistical tests like T-test, ANOVA test. Don't worry if you don't know them right now. You will know after a couple of lectures. So T-test, ANOVA test, linear regression, logistic regression you want to apply. So some tests, statistical tests, and some machine learning algorithm are not sensitive to skewed data. Even if you give them skewed data, they are not sensitive to it. Means they will still work well. You give them normal data, normally distributed data, or you give them skewed data. They work equally well. So you don't have to worry. You have to apply T-test, either you have to apply linear regression. Your assistant comes to you with, sir, data is skewed. Okay, don't worry. Go ahead and apply T-test or linear regression. Okay. Especially if skewness is mild or moderate. So you should bother that your skewness is between 0.5 to 1 or -0.5 to 1 Pearson coefficient. That's what you should bother. So if skewness is mild or moderate, you can still go ahead with this test. But if your skewness is very heavy, like if it is skewness coefficient is below -1 or above +1, then you are worried. Then you are in trouble. So if a mild skewness, you ignore it. Some of the algorithm will still work. Not everything will work. Some algorithms need normal data to be Gaussian distribution, data to be normally distributed. They will not work without that. but some are still okay. Okay. So it is best to ignore if or apply such methods which are not sensitive to skewed data. That is first thing. Data is skewed, slightly skewed. So apply such statistical methods which are not sensitive, which can tolerate skewed data. That is number one technique. Number two, use a different model. Suppose now you find out that your data is highly skewed, below -1 or above +1. So try to use those kind of models which can tolerate heavy skewness. So heavy skewness means below -1 or above +1 Pearson coefficient. So there are some machine learning algorithms which can tolerate heavy skewness. So heavy skewness means there are outliers in the data. Skewness means whenever there is skewness, that means outliers are there. Either on the upper side outliers are there or on the bottom side outliers are there. So heavy outliers, there are some machine learning models like decision tree models, then random forest model, XGBoost model, they can tolerate any kind of outliers in the data. If skewness is heavy, they can still work better. And if some statistical tests are to be applied, so there are some statistical tests which are called non-parametric tests, non-parametric tests which you can apply for heavily skewed data. So use those methods which work well even for heavily skewed data. So you have to go for specific machine learning models. You have to go for specific statistical tests. We should know that they work for even for heavily skewed data. That is one thing. So one is simple routinely used methods. They generally don't bother. If skewness is under control. So it is between -1 to +1. So some your common test which you apply, you don't have to bother. But if skewness is heavy, you have to go for some special algorithms or special statistical tests. That is number two. If skewness, and there is number three, transform the variable. 100 diameters measurements are there, and I name that column as diameter, and there are 100 diameter entries in that, different values, little variation to 10. So I want, due to some reason, I want data to be perfectly normal. But my data is heavily skewed. What to do? There are some statistical transformations available. Mathematical transformations available which can make your skewed data as a perfect normally data. You apply that transformation, your data is skewed, but after applying transformation, the data will be normally distributed. So like what is mean by transformation, guys? What is mathematical transformation? I'm using a heavy term. What is a mathematical transformation? Anybody? What is a mathematical transformation? Suppose in there is a diameter, there is an entry of 100 diameters, 100 values. And I say I am applying a mathematical transformation to this 100 values or this piece of column. In an Excel sheet, suppose in an Excel sheet, there is a column in which 100 entries are there, mathematical entries, numeric entries. Okay, numeric entries are there. And I'm telling you that I'm applying a mathematical transformation to this, or I want to apply a mathematical transformation to this. What do you mean by it actually? So if you don't know, I will directly tell you, take the log of it. Like every row, with the cell I will go. Cell, if suppose value is 10.02, I'll take a log, simple log of 10.01, log of 10.02, second, third, log of 10.04, fourth, third, then log of 10.05, fourth, log of 9.99, sixth, like that I will take log of all the values. So that is also a mathematical transformation. So what is the meaning of mathematical transformation? Applying some mathematical formula on it. So log is a mathematical formula. If apply log of it or log on it, so I'm doing a mathematical transformation. Or if I do exponential, I go to every cell and I say e to the power 10.01, e to the power 10.03, e to the power 9.97. All the diameter values I put e to the power. That is also a mathematical transformation. Or I apply one sin x. Sine of 10 to the power 10.01, sine of 10.02, so the sine of 9.97, sine of 9.99. All the Excel sheet I go and I apply sine theta on that. I calculate sine theta of that with the help of either Excel itself or I use a calculator. A simple applying a Excel formula, you can apply sine theta. So applying a simple Excel formula, you can apply log. So that is called mathematical transformation. So every mathematical transformation is different. Every mathematical transformation, suppose your shape is skewed. The shape of that column is skewed like this, left or right, skewed. And if you apply different formula, the shape of this curve will change. Every formula will have a different shape. Log will give you a different kind of curve. Sine will give you a different kind of curve. Exponential will give you a different kind of curve. Like that, you apply mathematical formula, different shape of curve you will get. So your curve will not remain the same. So similarly, there are some mathematical functions which are available, which you take when you apply on a piece of data, they convert your before applying that mathematical formula, your curve, all the cells, don't apply any formula. Your cell will be skewed like this. You apply formula to each cell, then plot it. Then it will be a normal distribution. So we are not getting into those transformation. Just you should know that there are mathematical ways to convert a skewed distribution to a normal distribution or Gaussian distribution. You should know only that by this time. And little more depth into you want to search, just search Google mathematical transformation to get normal curve. Just put mathematical formulas to get mathematical transformation to get normal curve, normal distribution. You will get those formulas. Apply those formula to each of the 100 cells and then plot it. You will get a perfectly distributed, normally distributed curve. So like that is also possible. Okay. So till this, guys, any challenge till this?
Sir, I have one question.
No.
Yeah, tell me.
Sir, like I have taken the count, like measurement of diameter of 100 nuts, 9.5, 9.6, and now we got the skew curve, positive or
Okay.
negative. Skew curve,
Okay.
right? More
Okay.
than 1 minus 1. And now we are performing the transformation to get the normal curve, right?
Okay.
And I get the normal curve also, right? So what is the purpose of getting the normal curve? Based on that, we again.
Yeah. No, I am telling you, if dealing with skewed data is difficult.
Yeah.
Formulas to deal with skews data is very difficult. But formulas to deal with a normal curve or a Gaussian curve are very simple.
Okay.
Way to deal with, if your data is once in a normal shape, means it is very easy to deal with it. And if it is in a skewed shape, it is difficult to deal. Mathematically, it is difficult to deal with it.
Okay, that means my volt is same in the different distribution, is a asymmetric distribution, but for the analysis for purpose and this we require to normal curve.
Now you will ask me a question. You should ask me, sir, what I can do. Suppose my data is normally distributed or whatever distribution I get. What can I do with this distribution? You should ask this question first. I have this distribution, but what can I do? Tell me how it is useful to me. You should tell me that. So I will tell you that in a couple of months down the line. So how to use Gaussian distribution, how to use a skewed distribution, that all we'll study in a couple of lectures down the line. I'll tell you all that. So suppose I have 100 plots of diameters. Diameters are measured and I entered in Excel sheet, 100 cells are filled up in a column. I plot them, values of diameter on the x-axis and their frequency on y-axis, and convert them into probability table. So probability on the y-axis and diameter on the x-axis. I have a plot. So I have a beautiful normal distribution is there. So what can I do with that? First question to you should be that only. That is the most basic question to ask. What can I do with a distribution? What is the advantage of having a distribution? What are things I can measure with the distribution? That should be the first question in your mind. Okay. So that is the curiosity you should have. So this curiosity, I will answer in, we have 2-3 lectures on distributions. So got it, guys? So if, for analysis purpose only, we are converting from skewed distribution to Gaussian distribution. Got it, Gajendra?
Yes, sir.
So analysis, if it is in Gaussian distribution, analysis becomes very simple. Very simple analysis. If it is a skewed distribution, you are little specialized people you are needed. You can do it, but you should have little specialized and little more knowledge of statistics. But if you convert it, apply some mathematical transformation, convert it into a Gaussian curve, then you already know what to do because it is very easy. So that is the advantage. Okay, guys. So this is, now we dealt with, so far we have covered what is skewness,
Yes.
how to measure skewness. Once you have skewness coefficient, how to interpret it. We have done one numerical on how to calculate skewness coefficient, PSN coefficient. Then we have studied this mean minus mode is equal to 3 times mean minus median. This also we know. And little bit how to interpret coefficient, what value, how to interpret it, we know. Then one more thing we have learned just now is, at least conceptually I have learned. Conceptually you have learned. I have not told you what transformation to apply to get a Gaussian distribution, but at least you know that there are some mathematical formulas or mathematical transformations available which can convert my skewed data to normally distributed data or Gaussian curve. You know that much. And if you want to know how, you are just a Google search away. Just write in Google search mathematical transformations to get a normal curve or to get a Gaussian curve. Like that you type, you will get 2-3 formulas, apply to all the cells of any one you have to pick up, okay? Or different cell, you have to apply the same formula. You cannot apply different formula to, suppose you have 100 measurements. All the 100 measurements, you have to apply the same formula. You cannot apply different formula because you have to apply only one mathematical transformation at a time. So once you apply that mathematical transformation and plot again, your skewed curve will get converted to Gaussian distribution. And now we know why we are converted to a Gaussian distribution. Now by this time we know that what is a negatively skewed distribution, what is a positively skewed distribution. So left hand side, if left hand tail is longer, it is negatively skewed. If right tail is longer, it is positively skewed. Both are equally bad. Okay. So that is how it is. And now we go next. So now we are dealing with, one thing I told you in the beginning itself, that whenever data will be skewed, our mean, median and mode will never be the same. But if data is normally distributed, mean equal to mode equal to median. But if data is positively or negatively skewed, then mean will not be equal to median, median will not be equal to mode. These three will be different. Now next step we are getting. What are the, how mean, mode and median and mode are placed in a negatively skewed curve? How mean, mode and median are placed in a positively skewed curve? That's what we want to learn now. My question is, how mean, median and mode are placed in a normally distributed curve? Tell me that answer first. If curve is perfectly normal, symmetrical curve, where mean, mode and median are distributed, located? Where they are located, guys?
Exactly at the center.
All the same, exactly the same place?
Yeah.
Now, okay. Now you see positively skewed, first of all, left hand side. Now left hand side is positively skewed, right? Because right tail is longer. So it is positively skewed. You see the position of mean, median and mode. See, mean, mode means highest repeating. Highest repeating. No? Mode means highest repeating. So its counts also will be highest. Y-axis, what is there? Y-axis is the count and x-axis is the value. So mode is the highest frequency, highest number of times which is the number is repeating. Suppose 100 is repeating 10 times, and 99 is repeating 3 times, and 95 is repeating 3 times, then 100 will be my mode, because it is repeating highest number of times. So if it is the highest repeating number, if it is the highest repeating number of times, then it will always be on the peak, because it is highest repeating thing. Count we are plotting on the y-axis, right? So highest repeating will be in the middle, always on the peak. You remember, see, in the right hand negatively skewed also mode is in the peak, and positively skewed also mode is in the peak. That is one thing. That is first tip to remember. Mode will be always on the peak because it is highest frequency, highest y-axis value. And y-axis what we are plotting? Count. So highest will be your mode always. Peak will be mode. So in both the curves, left hand side and right hand side, note the position of mode. Note the position of mode. It is on the peak. Now you have to remember the position of median and mode. So that is something tricky to remember. Median and mean. So mode will be always on the peak only. That is very easy to learn. Median mode. Just locate the peak, that will be mode. Now two things you have to see, median and mean. Median and mean. So in both the curves, it is little tricky to remember. See the positively skewed curve, which is on the left hand side. Median and mean. So see, mean is rightmost, which is dotted line, and in between you have median, which is in the middle. So in the middle of mean and mode, you have median. First of all, let us see positively skewed. So on the right, extreme right will be mean, extreme left will be mode, and in between them median will be there. Okay, it is logical also. Wherever data will lie more, their mean will be that side only, right? So data in positively skewed curve, data is more on right hand side data is more, because right hand curve is longer, so that side we have more data. So that's why mean will be somewhere in the right. So mean. So now tell me, in positively skewed curve, in mean, median, and mode, which value is longer? Which value is highest? Positively skewed. My question is mean, median, mode. Which value is highest?
Mode or less?
No.
Positively skewed.
Positively skewed.
Mode value will be higher.
No, mode frequency is highest, man. Y-axis is the frequency.
Okay.
Value is there on the right x-axis.
Mean will be
Mean is
higher.
highest, right?
Mean is
because
highest,
value
yes.
is there on the x-axis.
Yeah.
Mean is highest. Second highest is who?
Median.
Third highest is
Mode.
So now here, mode is less than median and median is less than mean, right? Mode is less than median and median is less than mean. Is that correct? Guys.
Yes, sir.
Mode
Yes, sir.
is less than median and median is less than mean. Correct now?
Yeah, correct.
Now see the negatively skewed. Mode frequency is highest. So y-axis will be the highest point. So peak will be always mode, because y-axis highest point we want. Y-axis is your frequency. So mode you got first. So mode is on the rightmost side. Then mean, because more data is there on the negative side, like in the left curve data is more, so mean will be on the left side. So mean is there at the dotted line. And in between you have median. Okay, so now in negatively skewed, which is highest, mean, median, or mode? Negatively skewed, which is highest?
Mode.
Second highest?
Median.
Third highest?
Mean.
Got it?
Yep.
You got it. Now, so how to remember, I will tell you. Mode, it is blindly you can locate. Peak of the curve will be mode. Everyone can locate. Now, how to calculate mean? See, now positively skewed means you know the right hand curve is longer. Right hand tail is longer. More data is on the right hand side. So what you will do? So the rightmost will be the mean. So if it is positively curved, means right hand curve is longer, so rightmost will be the mean. And in between them, always median will sit. So positive skew, when it is positively skewed, right hand tail is longer. So rightmost will be mean. That is how you have to remember it. Mode you can calculate, median will be on, mean will be on the rightmost side because right hand tail is longer. And median will always sit in between them. Now similarly in negative, mode will sit always in the peak. Mode will always sit in the peak. Mean will be always there on the leftmost side. Mean will be there always on the leftmost side because left hand side is longer tail. And median will sit in between. So like that you have to remember. Got it guys? How to remember it? Very easy to remember. Mode will be always be on peak. Mean will be positively skewed. I am talking now. Positively skewed mode always will be on peak. Mean will be rightmost side because it is right hand tail is longer, and median will sit in between. Negatively skewed. Mode will be on the peak. Negative tail is longer, so median will be on most negative most in median, and in between the median will sit. Got it, guys? How to calculate? Any challenge in this, guys?
No, sir.
No,
No,
sir.
sir.
In, Amit bhai?
No, sir.
Okay, so now here, same thing is repeated. I'm not stopping here now. You know that in when it is, this is positively skewed or negatively skewed, guys?
Positively.
Then you know that mean is greater than median is greater than mode. We have discussed this in detail.
Yeah.
This is positively skewed or negatively skewed?
Negatively.
Then in that mode is greater than median is greater than mean. I'm not going into more detail now because we have already discussed this. Now, I want 5-10 more minutes to finish. And I want to give you 2 minutes, only 2 minutes bio break I will give. Only 2 minutes because recording is on. In 2 minutes I'll start. Okay. So 2 minutes break I'm giving.
Sure, sir.
Amit.
The guys, are you there?
Yes, sir.
Yeah.
Yes, sir.
So we start back. So I don't want much time now. So see now, why study Skewness distribution? Why study skewed distribution? There is a spelling mistake here. SKEWED should be. It should be SKEWED. Skewed. There's a spelling mistake in the title. So why study skewed distribution? Skewness can be used to obtain approximate probabilities and quartile of distributions. Skewness can be used to obtain approximate probabilities and quartile of distributions such as value at risk and value at risk via Cornish-Fisher expansion. Okay. So now I ask you that fundamental question. Suppose you have some distribution in front of you, what you can do with it? So what you can do with it? You can find out approximate probabilities. You can find out quartiles of distribution, like quartile you can find out. Q1, Q3, those interquartile range, those things you can find out with the help of distribution, and you can calculate approximate probabilities, cumulative probability and all you can calculate. So how to do it, we'll see it later lectures. So now suppose you are dealing with data and finance. So now I told you we have to measure 100 bolts, 100 bolt diameter we have measured. But now instead of that, we are dealing with stock data. So I'm dealing with past year data. I'm dealing with 52 week. So 52 week means that stock value. Every week peak I have data. Every week peak I have. So I have 52 data points. Every week's peak I have. And so those 52 data points I have. Suppose Reliance stock. So Reliance stock peak value for every week. I'm having such 52 values I am having. Okay. So now with this data, I have to find out some some useful thing I want to find out. First thing, whether the stock which I am dealing is a volatile stock or not. It is a dangerous stock or not. Should I invest in that stock or not? If it is a very volatile stock, I don't want to invest in that. Very volatile means it goes either very high or it goes at either it goes below the 10 rupees or it goes above 500 rupees. Suddenly it falls below to 10 rupees. So it is called extreme return. It is called extreme return, uncertain return. So those kind of things I want to see. So suppose I plot that, I can plot that, right? I can take the value of stock on x-axis, frequency on y-axis or probability on y-axis. So if I plot that and if I find that the skewness in data is very high, if I find, just plot it or just calculate this simple Pearson coefficient. I calculate this simple Pearson coefficient of that data, or I plot it and I find out that skewness is very high. What do you mean by it, guys? What do you infer from it? It is a stock data. Skewness is very high. So what do you infer from it? Like, is it dangerous? It is good? It is bad? What do you infer?
It is dangerous because more volatile.
More volatile stock, right? So you have more outliers in that. Volatile stock means outlier will be there. Either it will go like value of stock is 10 rupees, so either it will go 2 rupees, 3 rupees, or it will go 500, 550 rupees. So the outliers are too many. So if outliers are too many, data will be highly skewed. So if skewness is more, looking the skewness itself, I'll say, boss, I don't want to invest in this stock. But if you see Reliance stock, you will not find this kind of skewness. It is a very, very stable stock. It is just like any security. Like people, you use it like gold. So Reliance stock is very stable. But recent days, if you see 24th January 2023, recently 2024 January, that Hindenburg report came about Adani Industries, Adani stocks. And they leveled a lot of allegations on Adani Group that you are doing this, you are doing that, many things, right? So people started selling their stocks in a hurry. And Adani lost 100 billions of market share. 100 billions market share within few sessions only. Within few stock market sessions, he lost more than 100 billions. So it has become a world record of fastly losing the wealth. It has become a world record. Like so fast, nobody has lost the wealth. So it is highly volatile. Now, these days, means if you plot from 24 January till today, Adani stock is showing very high volatility. So it is very kind of volatile stock. If you plot it, its distribution will be highly skewed. Its Pearson this coefficient also will go either minus below 1 or above plus 1. Too much high or too much below. Okay. So that is one advantage of understanding the skewness. In finance, direct advantage you got. Simple calculate Pearson coefficient. Very easy. Just put 1 or 2 years data into Excel sheet, calculate standard deviation, mean and mode, and calculate standard deviation, and just apply this simple formula to calculate Pearson coefficient. The Pearson coefficient is -2, -3, or +2, +3, +5, +10. Then you simply say, oh, Baba, don't deal with this stuff. Okay, if you want to be a safer. But if you are a very different kind of stock market player who plays with volatile stock, who likes to take risk, and you know that it will go towards positive high side, then it is a human decision. Then I don't have any say. But like I am a kind of very conservative investor. So I always want stable stock. I get 15% or 12% annual returns, I'm happy on my investment. Even if I get 12 to 15%, I'm happy. I don't want 30, 40% returns on per year on my investment. I'm okay with 12 to 15 also. But my money should be safe. That's how Shailendra Kadre is. But somebody like might think differently. And they want to put in volatile stock. They are thinking that it will go very high. Oh, your decision, by your money, your decision. You do whatever you want. So that is the one advantage I told you with plotting the simple plot stock data and see the skewness. Now there are cricket score of suppose cricket team cricket store also score also you plot. So simple Sachin Tendulkar is played 300 matches and his score you plot 300 matches score. Sachin Tendulkar is a steady performer. So its skewness will not be high. But if you say any bowler generally will be out on 10, 15, 20, like that he will make. Or if sometime he's very lucky, he will make 70, 80. And sometimes very, very lucky means he will put century also. But very, very rare cases. So skewness in this course will be very high. So that is one example of skewness. Stock market is another example of skewness. I told you one direct application of skewness. You are all Gujarati boys. You all must be investing in stock. Just take the data and plot the skewness. That is the advantage of studying statistics. Just plot the skewness. Just calculate the Pearson coefficient. You know now how to calculate, right? So that is how you have to interpret skewness. And skewness, like what is kurtosis? Now there is another one more measure we will see. Skewness measures what skewness is measuring first of all. See here, skewness, if data is skewed, the skewness is measuring shape of the curve. Skewness is measuring shape of the curve, whether it is perfectly symmetrical, whether left tail is heavy, whether right tail is heavy. That's what it is measuring, skewness. But now there is one more reason. There is one more. Suppose data is perfectly symmetrical. Suppose data is like this, perfectly symmetrical data. I show you this data. All these three curve, Mount Everest also is a very peak curve also, it is symmetrical. Then second curve also, and third curve which is flat but symmetrical. All are normal distribution, different shape. All are bell shapes, all are normal distributions. So now in this case, your skewness Pearson coefficient will be 0, or it will be between -0.5 to +0.5. All the three cases. Then how you differentiate between these curves? Mathematically, with Pearson coefficient, you cannot differentiate between these curves because for all these curves, the Pearson coefficient will be near to 0 or between -0.5 to +0.5. So you cannot use Pearson coefficient here because all are symmetric curves. Pearson coefficient you can use only when asymmetry is there. Here there is no asymmetry. Then how to calculate? Still these curves are different. See, you can see curves are different. How to define them? So we define them with the help of one more new mathematical concept which I am introducing. It is called kurtosis. Kurtosis is that on the name of a German scientist, Kurt something, German scientist name was there. So some part of his name they have taken and defined this coefficient kurtosis. With the help of kurtosis, you can you can measure the flatness of the curve. So if, see now it is example here. If curve is very sharp, peak is very high, then it is positive kurtosis. I'm not defining kurtosis. First try to feel it. If curve is very sharp and peak, it is positive kurtosis. If curve is symmetrical but flat, it is negative kurtosis. If curve is flat and still symmetrical, but that will come in negative kurtosis. And there will be a curve which will be very pleasant looking, normal curve in between them, positive and negative. So that is your normal kurtosis equal to 0. There will not be any kurtosis. So like positive, you understand, positive means peak is abnormally high. Negative means it is abnormally flat. That is how positive and negative. In between, normal will be there. That is your normal curve. That is, I think, 0 kurtosis. So let us define. Skewness essentially measures the symmetry of the distribution. You understand? Skewness means symmetry. Skewness is there means curve is not symmetric. While kurtosis determines the heaviness of the distribution of the tails. Kurtosis determines the heaviness of distribution tails. Heaviness means, if negative kurtosis, tails are longer, so tails are heavy. So it measures the heaviness of distribution of tails. So if negative kurtosis means tails are heavy, curve is flat. If positive kurtosis means tails are not heavy, tails are very, peak is very sharp. So tails are not heavy. So it is measuring heaviness of the tail. If tail is very heavy means curve is flat. That is negative kurtosis. Okay. So you got it now what kurtosis measures. Understanding the shape of the data is a crucial action. We know that. You should know either first you should know whether data is symmetric or asymmetric. You use Pearson coefficient. Once you know data is symmetric and support it is symmetric, you should know what is the kurtosis. What is the how heavy are the tails? You should know that. So that is measured by kurtosis. To understand, most information is lying between. So here, so you should know what. Do you know now what is kurtosis? Guys, it is understood.
Yes, sir.
Yes,
Now, in finance, kurtosis is used as a measure of financial risk. One more thing we are finding as a measure of financial risk. Large kurtosis is associated with high level of risk in investment. You calculate kurtosis. I'm not taking into kurtosis formulas. They are little complicated. But if you are interested, you can always Google them. What is kurtosis formula? I would just want you to learn there is something called kurtosis, which you can very easily calculate. Like there are some formulas. After this session, I will show you on the web, but little complicated to discuss in this class. So if kurtosis value is large, the risk of level, the high level of risk in an investment. If large kurtosis means peak curve like this, positive kurtosis. On the other end, small kurtosis assigned a moderate level of risk. So just calculate the kurtosis formula I will show you. If kurtosis value is small, then risk is moderate. If kurtosis value is high, risk is higher. Okay. So now you see the field. This middle curve is kurtosis equal to 0. If it is positively kurtosis, like kurtosis is greater than 0. And if it is a flat curve, kurtosis is less than 0, negative kurtosis. Kurtosis equal to 0 means it's a normal. Kurtosis greater than 0 means more positive means the peak will be higher, more sharp curve will be there. Negatively more negative, more -10, -20, -30 means curve is more and more flat. If number is -20 and number is -30, kurtosis. One curve is having kurtosis -20 and one curve is having kurtosis -50. So -20 curve will be, -50 curve will be more flatter than -30 kurtosis curve. Got it, guys? So there are some statistical terms for this. Positive kurtosis is called leptokurtic. You remember, don't remember, it is okay. You just understand positive, negative, that is okay. But just for academic interest, I'm teaching you. Positive kurtosis is called leptokurtic. Negative kurtosis is called platykurti. And normal distribution, which is the normal kurtosis equal to 0, that is called mesokurtic. It is just for your academic interest. Even if you don't remember, it is okay. But you should know what is called positive kurtosis, what is negative kurtosis, what is kurtosis equal to 0. If kurtosis is very high, what does it mean? If kurtosis is low, what does it mean? If kurtosis is high, risk is high. If kurtosis is low, risk is moderate. Like that you should understand. Okay. Now last slide for today. See, now middle curve here, middle curve is having kurtosis equal to 0. Now the flat curve, the first curve, flat curve, that is having kurtosis negative. The top curve, which is peak curve, that is having kurtosis positive. So they have defined one curve, measured it, how to interpret, they have measured it. So excess, this 3, the shaded one, excess kurtosis equal to Kurth minus 3. Calculate the Kurth with a formula. I'm not showing you the formula. We'll see after the class. I'll just show you for a glance in the web. So, see, calculate the something called Kurth you have to calculate. You calculate Kurth and deduct 3 out of it. So that will measure the highest excess kurtosis. Excess kurtosis means if kurtosis more than normal distribution means positive kurtosis. Positive kurtosis means kurtosis greater than 3. Means if this excess kurtosis comes positive, 0 or greater than 0. Excess kurtosis comes greater than 0, 0.5, 1.5. So that is called lepokurtic, positive kurtosis. If kurtosis equal to 3, means excess kurtosis will be 0. If Kurth equal to 3 means 3 minus 3 equals to 0. Excess kurtosis is 0 means it is mesokurtic. And platykurtic means short tail distribution. Short tail distribution, it is kurtosis is less than 3. Means this excess kurtotic will be negative. A simple formula is there. So 3 they consider, Kurth equal to 3 they consider normal. Above 3, below 3. Like that they consider. So excess kurtosis you have to measure. And if it is positive, kurtosis is called positive. And if it is the excess kurtosis is negative, it is called negative. So like this, simple, you should know. And so with this, I end today's lecture. And as I told you, I'll show you the formula for kurtosis. Formula to calculate Kurth. Google God knows everything here. Kurth. Okay. Kurth function. Is there any function? Returns the kurtosis of data set. See, if you have a data set, suppose you have 100 measurement of diameters and you want to calculate kurtosis, there is direct formula in MS Excel. In MS Excel only we'll put now. MS Excel. See here, formula is simple formula. Enter the values into cell. So suppose you are measuring diameters, 100 diameters you enter in the cell. Choose the cell, all the 100 value you choose, and on the top of the cell you type 100 equal to simple apply formula. Just you know how to apply formula in Excel, right? So instead of writing anything, just write Kurth, K-U-R-T, Kurth, and highlight the cell. Select all the cells and just press enter. You will get the Kurth. You will get the value of Kurth, K-U-R-T, Kurth. Once you have the Kurth, you do this thing. See how easy it is to calculate Kurth in Excel. Put in Excel all those values, because any measurement you will take, at least you will put in the Excel to measurement, and if you to keep it safe, you will put in Excel, right? Once you put in Excel, in one simple formula you can calculate kurtosis. Just follow these 5 steps. Write Kurth, Start the bracket, select all the cells, close the bracket and say enter key. You will get the value of Kurth. Then once you have the value of Kurth, then come to this particular PPT and calculate excess Kurth. Calculate excess Kurth. So whatever Kurth value Excel sheet will give you, Kurth value, just deduct 3 from there. If that excess Kurth is positive, then it is a positive kurtosis. If the excess is negative, it is negative kurtosis. And both negative, positive, high values. That means high risk is there. If Kurth value is small, then you should understand it is a moderate risk. See how statistics, whatever formula is there, we are not bothered. Excel sheet is giving in one shot this step. One shot Excel is calculating Kurth for us. It is not a rocket science at all now. Okay, now, but this is with Excel sheet. Okay. Now I wanted to have a look at formula also. So formula, just have a look whether it is don't apply it in Excel only, but see the formula. See, this is the formula. See here, formula.
Sir, you are not sharing your screen.
Can you share the screen, sir?
Oh, I will share this. Oh, sorry guys, sorry. I'll share the screen. You could have told earlier, no, guys. Share the screen. Share the screen. Okay. So I was showing you. First of all, first see formula, Kurth function. Kurth you have to find out, na? So Kurth formula you see. This is the Kurth formula. This is formula. And xi minus xi whole square and n plus 1 and 1 divided by 3 and minus 3. Impossible to apply manually. You cannot apply. A is the standard deviation. So you cannot apply this formula manually. You see this formula, guys, right? Hello?
Yes, sir.
Can you apply this formula using copy pen?
No,
I
difficult.
don't think you can apply this formula by using copy pen. And
Yeah.
get to on a set of values, yeah, 100 to 100 values. You cannot apply, impossible. Only computer can do this job. So, don't apply. I just shown you the formula, okay? Just see the formula. It is very complicated. And I want to show you. See, now it is how easy to calculate. 100 diameter of the 100, same example I am taking. Bolts you are measuring, diameter you are measuring. 10 mm is the perfect value, diameter. 100 different parts you measure diameter. 100 values will come, none of them will be equal. Repeated value can come, but none of them will be 10.00. Either 10.01, 10.05, 10.05, 9.99, 9.999, like that values will be there. Some will be very slightly low, some will be slightly high. So all the 100 values you enter in a cell, Excel sheet, apply this formula. Kurth, cell, go to any new cell, top cell you click blank, just type equal to Kurth, start bracket, select all the 100 values, close the bracket and press enter. You will get the value of Kurth.
Like some function, sir. Like some function we are using, right?
Yeah, any function it is just like any other function. You should know that this Kurth function exists. And suppose you want to calculate standard deviation, just put SD. Instead of Kurth, just put SD. You will get standard deviation. You want mean, just put mean, median, mode. Anything you want, just put it here in the words, capital words. And you will get it. Same way, same for mean, median, mode, standard deviation, variance. Kurth also it is giving you. Kurth also it is giving you in one shot. But formula is like this. Formula is this. This is the formula.
It is same available in the Python scripting also when doing the
Python from function will be available for Kurth. We'll see right away now why you want to Python function Python code to calculate.
Just I am asking because I am working on the Python
Wait,
transformation.
yeah, I'm giving you the code itself. No, why you are worried? Code to calculate kurth. Okay. And see, this is very even easy work is to do work with ChatGPT. ChatGPT, it is not responding. See, ChatGPT you ask Python code. I'm in ChatGPT now. Now enter. It is hanging here. It is out of load now. Okay, we'll see in the wave only. It is out of load now. Too many people are working. Just put stack overflow. Now you will get code. How to SciPy? It is there in SciPy and Kurtosis stack overflow. Na? So here is used in SciPy. So SciPy, NumPy, answer. Okay. Random normal excess kurtosis. See here. See, you have some. He has created a random variable x between 0 to 2. He created 0 to 2, 10,000 values. Between 0 to 2, he created 10,000 values. So he got. So suppose we are measuring bolt, we have 100 values of the bolt. So we can put our data here. He is just randomly generated. Now here, in just half a line of code, you can calculate kurtosis. Just say kurtosis x. Your data column kurtosis x. That's all. That is excess kurtosis. It will give you excess kurtosis. Huh? And skewness you want to calculate skewness x. Skew x. I'll make it a little bigger for you guys. I'll make it a little bigger. Now you can see, guys. Now,
yes, sir.
You can see this code.
Yes, yes.
Just to see kurtosis. This will give you excess kurtosis. It will calculate kurth minus 3. So it will give you kurtosis means kurth minus 3 it will give you. If you want value of KURT, just add 3 to it. So it will give you excess kurtosis, right? And if you want to calculate skewness, just do skewness. So X is nothing but your data column. And what you have to import? You have to import, I think.
Which library is
library? See here. SciPy.
Okay, sent.
See here, note down. I'll give you this in the. I'll give this code in the chat.
Yeah, I know that this we can use the library all the thing. I'm working on that.
I will give you in the chat. See here, all these things you have to import, and this is the line of code. This is the line of code. Line of code for you. Access
this library used for statistics, right?
Yeah. See, this is the line of code. But you remember, right? It is calculating excess kurtosis. So it is giving kurth minus 3. Understood, na?
Yes, sir.
By kurtosis means he means excess kurtosis. So it is giving kurth minus 3.
Yes.
Okay, guys.
Yes.
And Excel sheet also you can get in one line here. So you calculate kurth, KURT kurth, and then do minus 3 from it. So you have to remember two things here. Kurth is a direct function, and kurtosis minus kurth minus 3 is kurtosis. Okay. So these two things you have to remember. By Excel sheet, you are getting KURT. So you have to deduct 3 from it to get kurth. Here, it is directly giving you this particular Python code is directly giving you this particular Python code is directly giving you kurtosis. This code, this particular code. This I am directly giving you kurtosis. So it is directly deducting 3 and giving it to you. So either positive kurtosis, negative kurtosis, or 0. So both positive 0 is bad, negative 0 is Positive big is bad, negative big is bad. High risk. So that's how we end here. So now you know a lot about kurtosis and all these things. So what is next? What next we are going to learn? So next is now we are going to correlation, covariance, difference between covariance, coefficient of covariance. So now we are going to learn covariance and correlation. Regression. Regression is taught in machine learning, but basic regression is expected in statistics also. Basic statistics, people also should know basic regression because it is most basic statistical model. So we'll learn statistics. Then we'll learn about hypothesis testing. I told you now this p-value method, then point interval estimate, hypothesis testing, critical value method, p-value method. Then we'll learn about t-test, ANOVA test, chi-square test. All these statistical tests also we'll learn eventually. So a lot of interesting stuff. This is all now we are getting more deeper and deeper into statistics. We started with very basic, what is statistics? And now we are in the somewhere 30% completed. So now all these things we are going to study. All these things we'll study. T-test, pair test, ANOVA, chi-square. All this we'll study one by one. And what is the use? Why we study? Suppose I have a distribution in front of me. What can I do with it? Suppose distribution is skewed, non-skewed or symmetric, perfectly symmetric. What can I do with it? What statistical parameter, what measurement I can take with that distribution? All that we'll learn. And one more thing I wanted to tell you, I will share this slide tomorrow with you. And here you have something here. You should see this 10 skewed distribution real example in real life. 10 skewed distribution example in real life. So stock market is and finance is just the one example where we can use skewness, advantage of skewness and kurtosis. There are 10 more business examples are given here. Different situation, how you can apply this knowledge which you have learned today. So this article you can read. Everything I cannot teach in the class. So this article you can read. So any questions, guys, so far?